Thank you. Hi, everybody. 10 years ago in Mistelbach, I presented the idea to create database of MEteoR likers. But however, I'm suffering from shiny object syndrome. So when I finished one project, I have idea to another project and so on and so on. So for me, it's very hard to finish some project. But with the age comes some experiences, and so I decided to dust off this project because a tool like this still doesn't exist. So MERLIN was born. What is MERLIN? It is it has 3 parts: meteors, Lightcurves, and investigation. Meteors are core database of single station observation, and second, Lightcurves is a calculation of 3D trajectories and through light curves, and investigation modeling the physical parameters, properties of meteoroids. So MEteoR databases, it will be very robust and comprehensive databases because it will contain data about all measured points of all meteors that is input to the databases. It contains 3 tables, and the main table is MEteoR. It is information about MEteoR, clip name, year, month, etc. Number of frames, f start, f frames end, counts if it is interlaced, frame per second. Second table is table with information about station. Next is information about camera, and the largest one is information about curve. This one data will be calculated, yes, because will be used in the next parts. It look like a MEteoR table. It is part of some meteors. You will see that first letter M means Sonotako data, and R is data from metric. Next one, station. This one we calculate also geodetic and geographic position and SF coordinates of the station, and there are some information about system. We need operator and system in which was MEteoR captured. And the large one is table curve, the most granular table storing detailed data for each individual point measured along the meteor's path, including its brightness, magnitude, and position, azimuth or elevation. So currently scripts have been developed to parse data from UFO capture and the metric systems. And for UFO capture, the large XML file provides all necessary data. Metric is more complex, requiring data from in, ref, and supplementary table. The goal is also incorporate data from CAM's Gemini all-sky 7 system in the future, and of course from other systems. But the problem is that the data are spread by to computers of each observer, and it is hard to collect this data on the one place. Okay. So current status. The project is currently in the data acquisition phase, thanks to Circo and Jakub Koukal. The large amount of historical data is being processed. The major challenge is that original files are often not archived, and appeals to all observers: please archive your raw data, because many observers send only data to some database, and original data delete. And it is, you never know, it might become valuable. The scale of database. The database must be organized by year due to the sheer volume of data. Example, 4 stations of from cement captured over 40,000 meteors, resulting more than 500 to 40,000 measured points. So future estimate is that this project to grow to 10 million meteors and 120 million of measured points. So, but single station data give us only basic light curves, and they lack spatial data and tube brightnesses. To conduct the real scientific analysis, we need to know meteors' 3D position, absolute magnitude, trajectory, angle, and velocity. This is the goal of the second phase, calculating 3D curves. The process involves several key steps. From the first database, we find multi-station meteors, match events within plus minus 10 seconds time window, because not all station keep precise time. It is also appeal for you. And filter out meteor with fewer than 5 measured points, because it is not a live curve, it is only some peak. And then find the intersection of these planes with the lines of sight from other stations of this meteor for this meteor, and then calculate the final direction vector using least squares method. Monte Carlo will be probably very time consuming. So then data refinement and correction. Correct observation times for each point, and the referencing time will be the highest observed point in the atmosphere. And correct brightnesses for atmospheric extinction and for distance, and average corrected light curves from all stations. And finally, determine meteor's radiant, zenith angle, velocity, and any deceleration. Final phase, how many?
1 minute.
1 minute. Focuses on the scientific analysis of the 3D light curves. The main goal is to model the meteorite before it entered the atmosphere. We aim to determine key physical properties like density, initial mass, and KB and PE parameters. And application is being developed to model other parameters such as shape factor, luminosity efficiency, drag coefficient, and heat of ablation. So scientific application model individual meteor streams, compare homogeneity of different streams, analyze annual variation within a single screen, and many other. And conclusion, it is very ambitious undertaking, and suggestions for improvement are welcome. So, any question? One.
Maybe one quick question if someone has in the room. If not, then we'll move on to the last talk of this. There's an online question. So don't run away. Galina is raising their.
May I? May I? Or not?
Yeah.
Yes. Thank you, Roman, for this presentation, but I wonder, do you have any successful sample of calculations of this profile?
Yes, I have. But I can send you by mail or so.
Geminis, please.
Okay.
Thank you.
Okay, bye.
Thank you once again.